Welcome Math 30-1 to your lesson on transformations of trigonomic functions. In this lesson, we're just going to be looking at our vertical and horizontal stretches. So in other words, we're going to look at how A and B affect the sinusoidal function and how A and C affect the cosine function. So let's take a look at question number 1. It says, use your knowledge gained from transformations to describe how the graph given the function compares to the graph of y sine x, where x is in degrees. So right here, if I look at this here, this 2 is in front of my function of sine x. So that's the same thing as y got replaced with 1 over 2 y. Okay? Now if I look at that, this means we have a vertical stretch by a factor of 2 about the x-axis. Okay? Now here we have my 2 is by the x. So that's like saying x got replaced with 2x. So this means we have a horizontal stretch by a factor of 1/2 about the y-axis. Okay? Now my next one here, we have -3. Okay? So what happens in this one? Well, that means y got replaced with -1 over 3. So first of all here, I'm going to have a vertical stretch of 3. About the y-axis. About the x-axis. And we're also going to have a reflection about the x-axis because of the negative sign. Okay. Now the next one here we look at, we have x is replaced with -3x. So let's start off, as remember Stinky Rotten Tomato, stretches first. I have a horizontal stretch by a factor of 1 over 3 about the x-axis. And I am reflected because of the negative about the y-axis. Okay? Now part B says, which of the above examples is there a change in amplitude compared to the graph sine x? Well, I look at change in amplitude, that is referring to my stretch vertically. So if I stretch my graph vertically, I'm going to be changing my amplitude. So I have here an I and 4, so 1 and 4. Okay? Oh, sorry. Not 1 and 4. 1 and 3. Sorry, 3 is the other one. Okay? So we're looking at the ones where we change A up on top. Okay? Now it says, which of the above changed the period? So period is going to be kind of like stretching it horizontally. So in this case, we're looking at my B's will be my period. So we want to see which ones change my B. That's going to be number 2 and number 4. Okay? Now it wants us to complete the table and use a graphing calculator if necessary. So if I'm going to complete this table here, we're going to start off with y sine x. My amplitude in this case is going to be 1, and my period is going to be, we're going to put it in terms of 360 in degrees. Okay? Now complete the, next is sine y is equal to 2 sine x. Well, this one right here, we multiply my amplitude. We're stretching it twice as much by a factor of 2. So my amplitude is going to be 2, and my period is still going to be 360. My next one here is sine 2x. Well, in this case here, we're stretching it by a factor of 1/2, but my amplitude stays the same, but it's horizontally being stretched by 1/2, so it's kind of like compressing it. So this is going to be only 180. Next one here is -3 sine x. Well, my amplitude, once again, we're stretching it vertically 3 times my original, so it's going to be 3. And my period is still going to be 360. Nothing changes to period with that one. Now I put sine -3x. Well, if I put -3x, well, my amplitude isn't changing because there's still a 1 in front, but my period now is 1/3. We are multiplying by a factor of 1/3. So I multiply my period by 1/3, that's going to give me 120. Okay? Now it says here we have a 5 in front, so this we find out is always my amplitude, and we have 4x there. So that's going to be 360 divided by 4, or 360 times 1/4, which is going to give me 90. Next here we have 1/3, so that's going to be 1/3 is going to be my amplitude, and we have 1/2 there, so that's going to be like 2 times 360, which is going to give me 720. Okay? So now when we're looking at A sine B, well, my amplitude is always my A value, and it's the absolute, because it doesn't matter if it's negative or positive, we just always have it my A value, and my period is always going to be 360 divided by my absolute value of B, okay, which is my B value here. Okay, so it says describe the effects of the parameter A on the graph. Well, A is my amplitude. Okay? Then it says describe the effects of B. Well, period is affected by B is equal to, well, it's just going to be 360 over absolute value of B. Or if we're in radians, that's 2 pi all over my absolute value of B. Okay? Now, would you expect similar effects for the cosine graph? Yes, they would be exactly the same, the cosine, because the only difference with cosine is, and sine is, well, if we look at sine, well, sine 0 starts right there at the origin, and then it goes up and then down. If we look at cosine, cosine starts cosine of 0, that's my x value at 0. X is going to be long. If we look at my trig circle, at 0, my x is long, y is 0, so then we're going to start up here and then go down like that. So that's the same thing. They're exactly the same, except they're shifted over slightly. So yes, we're going to have the same. So basically here, we're just going to go over our rules that we learned so far. We know that amplitude is equal to max minus min divided by 2, which is also equal to A in my graph. Okay? And we also know that period is equal to 360 divided by B. That's for degrees, so that's my period. So period, or 2 pi divided by B for radians is my period. Okay? Now, when we look at tan, this is going to give us something a little bit different. All right, tan is going to be a bit different from cosine. Now, tan is only going to be 180, because if we remember, tan is the same as y divided by x. Okay? Now, when x is 0, we cannot have, it's undefined. Okay, it's going to take us a lot, our periods are actually half the size, half the amount as my cosine or sine. So in this case here, period for this is going to be, we have to look at my B, is going to just be 180 divided by B. Okay, and pi divided by B. So let's take a look at question 2. It says consider the graph 4 cos x, or 4 cos 2x between 0 and 2 pi. State the amplitude and the period. Well, first of all, I know my A value is equal to 4. Okay? And I know my B value is equal to 2. Alright? So if I look at this, my A value is my amplitude. So my amplitude is equal to 4. Now my period is equal to 2 pi over b, because we're in terms of radians here, because we're in pi, so it's 2 pi over b. So in this case, my period is equal to 2 pi all over 2, which is equal to pi. Okay? So given this information, now we could actually sketch my graph. So my amplitude is 4, and we're doing cosine. So if we remember in our trig circle here, do a quick little trig circle on top. When cos is 0, at 0, cos is maximum, it is 1. It's equal to my radius. So here my amplitude's 4. 4 times 1, we're going to go all the way up here to 4. Okay, my period is pi, so then the next time I'm going to be up there is going to be at pi. Now I look at this, pi over 2, so we have 1, 2, 3, 4, 5, 6. So I'm going to say it's going to be somewhere down here. And here are my intersections away, so I'm dividing into kind of fourths. And we go all the way down. That. It's going to go up. And then we're going to be back there. And at 3 pi over 2, which is somewhere around here. Back. So my graph is going to look something like that. Okay, so number 3 says, write the equation of a sine function having an amplitude of 2 over 3 and a period of pi over 6. So I look at this here, a is equal to 2 over 3. That's easy, okay? But now my period being pi over 6, that's a little bit more trickier. So we know period is equal to 2 pi over b. Well, I know my period this here is equal to pi over 6 is equal to 2 pi over b. So now I'm just going to try and cross multiply here. So I'm going to put that there and cancel these out, that there. So my pi's will cancel out. I'm going to get 12 is equal to b. Okay, so we have b is 12. And I have a is 2 over 3. So if I want to write this out, it's a sine function. We're going to have this right here. I'm going to put it over here. We're going to have y is equal to 2 over 3 sine 12x. Okay, and that will be my answer. So now let's take a look at b. It says a cosine function having an amplitude of 3 and a period of 720. So now I want a cosine function with an amplitude of 3, so we know a is equal to 3, and period of 720, so we know period 720 is period is equal to 360 over b. I rearrange that, I'm going to get b is equal to 1 over 2. So if I put this in here, I'm going to end up getting y is equal to 3 cos 1 over 2 x. And we're looking now at a tangent where the period of pi over 2. Okay, so period of pi over 2. Now if you remember, tangent is going to be pi, period is equal to pi over b. So we have, in this case, pi over 2 is equal to pi over b. Well, b must be equal to 2 then. Okay, so we have b is equal to 2. So in this case here, we're going to have y is equal to tan 2x. Oops, put my brackets like that. Okay, so number 4 wants us to state the amplitude and period of this following graph right here. Well, I look at it first for the amplitude. My max is 3, my minimum is -3. So in this case here, my amplitude is going to be 3 because we have a stretch of 3 times about the x-axis. Now I'm going to look at my period. We go from here all the way to there is 1 cycle, and we're counting by half pi's, so my period is going to be equal to pi. Okay? Now it says determine the equation of the sine function. Well, how do we know what it is, the sine function? Because we're starting right here at the origin, and we're not starting at the top of the graph. Now determine the equation. Well, I know my a value is equal to 3. Now we just have to find my b value. So we can rearrange our one formula to get b is equal to, in this case, 2 pi divided by my period, which is pi. So in this case, b is equal to 2, so it's 2x. Number 5 says, the graph represents the mean of tides over a 24-hour period. In the equation, h of t is equal to, well, so we have a function of time, is equal to a cos b of time, where t is in hours and h is the height in meters. Okay? So we want to now figure out here, it says, determine the equation of the graph. So we want to figure out what is the actual equation of the graph. So now I'm going to look at this. My amplitude, my a value is 4. Okay? Now we also want to look at my period here. My period is going to be, I look at from here to here, so we're going 3, 6, 9, 12. My period is equal to 12. Now I have to figure out what is my b value. So period 12 is equal to, and we could either do this in pi's, in radians, or we could do this in degrees. So I'm going to do this one here in radians, since radians is a bit smaller. So I'm going to put 2 pi all over b, my absolute value. I rearrange this. I'm going to end up getting b is equal to pi over 6. So my equation is cos, here we go, we're going to have h of t is equal to 4 cos pi over 6, and we want my t. And that is going to be my equation.